So I've started recording, and if anybody has any questions about GSA, you can feel free to reach out to me or anyone on the committee, on Slack or on email. So I'm going to hand over to Johannes and César, and once again, thanks again, guys, for offering to lead this workshop.
Thank you very much, Tak. Well, welcome everybody to our workshop, a short introduction to LaTeX. So Johannes and I, we're going to try to give you an overview, basic steps of LaTeX, so that you finally can write your first text on LaTeX. So that's our main idea. So this workshop is going to be divided by this presentation, and then Johannes is going to lead the hands-on part at the end. So here I'm going to try to give you an overview of LaTeX, so then you can have the basic knowledge to give the pass to Johannes, then you can practice all of this part. So let me start. So what is LaTeX? So here, this is the first question that we're going to try to answer. Then why or why not use LaTeX? Then we're going to see some basic concept. Then we follow with important commands and some example. And then at the end, we're going to see some resources and help that you can find online in the internet. So what is LaTeX? LaTeX is a typesetting system originally written by Leslie Lampert, which uses text as its formatting engine. Text basically is a computer programming for typesetting text and mathematical formula created by Donald Knuth. And the main idea is that we split the writing and the formatting of the document. So the idea of LaTeX basically is you have your formatting that is predefined, and then you just focus on writing. That's the main idea of this. So for this, you need to know some special commands that give the software information about the structure of the document, that you then will be, this ASCII file will be translated by a program or compile it to make a PDF or a PostScript document. Sorry, guys, if I forgot to tell you at the beginning that if you have any question during the presentation, please ask by the chat. And Johannes is going to try to answer right away. Or otherwise, at the end of the presentation, of course, we're going to have some time for questions. So what we can do with LaTeX? So for example, here we have a paper. This is one of the examples. So in this case, we use a class called article. And this class is used, so many journals now are doing this template. In this example, this is a template from the journal Fluid Mechanics. So here, all this formatting is presetted, and you just need to fill with this command that we're going to show you after, and you just focus on writing your text. Also, you can write book or your dissertation using the document class book. So here there is different setup. So you have chapters, you have sections here. You can write beautiful equations in a different setup, in a different format. Also, you can create beautiful curriculums. Here we can see the curriculum of Johannes. So in this case, for example, all of these lines here, or this formatting of the name here, or the setup of the figure here is predefined. So you just need to fill the spaces, and LaTeX is going to be the formatting for you. So why or why not to use LaTeX? So the pros here is that, as we saw before, is LaTeX produce beautiful, high quality documents, especially nice for equations. Also, it's an open source with a lot of add-ons. So it's free. You can download it and install it in your computer, and you can use it free. Also, is just you use a text file. So it's good for version control using, for example, Git, and also for collaboration. Uh, Also can be included in automatization. For example, you can use R. I know that many people in Gleon use R to write an entire, for example, little report of your main result, and you have to, again, set up this, and you can fill it right away in the LaTeX document. And then, well, that is not maybe some people could say that it's not a pro, but it's some way it's easy to change the layout of the whole document. We're going to see after some of this. Also, you can create this table of contents very quickly and very easy, or table of the figures, or table of tables, for example, in your books. It's very easy to do. And of course, all the cool kids use it. So you're going to be one of us. But the cons, well, the main con is that it can be confused at the beginning, because it's not like, for example, Word, that you see what you get. You write as the way that you're going to see your final document. In LaTeX, it's not like that. So you have a document that you will write with some comments, with some maybe for some people strange, weird comments. But at the end, it will create a PDF that is going to look different in that your text file. So in the beginning, it's hard to learn, I have to say, and most probably it's going to be frustrating at the beginning, but you can find all you need online. And then if you learn it at the beginning, then it's going to be straightforward, and you are going to be able to write faster your document. So another con is that not everybody knows it. So so many people, if you want to share your document and edit it for other people, maybe they don't know to use LaTeX, and they don't know these commands, and they get confused. So maybe you could have a problem with that. So this is one of the main reasons that motivate us to do this workshop, so that more people know how to use it. And then again, the layout is mostly predefined. And to design a new one maybe is challenging, but you can find so many layout on internet that I don't think that is mostly needed to change the whole layout in LaTeX. So this is a structure basically of a document on LaTeX. So here we start with the document class. In this case, is article. Then it will follow a preamble. And then here we have our document, our main document. I'm going to explain you after all of this part, but this is more or less how is the document structured. So the document class is going to define, as I said, the class. So for example, articles, books, or Beamer, that is presentations. For example, this presentation is made in LaTeX using this document class Beamer. So you will define here, for example, in options, the size of your letters, the size of your page, and stuff like this, and you define which type of class. And then it will follow by the preamble, and then you're gonna create this environment document while will you write most of your document. So what is the preamble then? So it's the area between the document class and the document environment. And here you will load different package. For example, here we have the package abstract that it will provide you an abstract environment for your document. Or we can use the hyperref will allow you to make a cross-reference in LaTeX that they always work, I have to say. Or here we have the NatBib, that is a package for manage your bibliography and citation. And many of these you can find on internet for many things. But then in the preamble, you can set up your main outline formatting of your text. So for example, here we can set up the style of your bibliography, or you can, in this case, that is a Beamer document, you can set up your color theme of your presentation, or set up your frame number in the foot line, like in here. So this is, for example, how can you start a presentation? So you can set up also your title, your author, the author name, and stuff like this. So let's see the LaTeX command. So the LaTeX commands are case sensitive, and they follow two main formats. They start with first with a backslash, and they have a consistent of letter only name, and they are terminated by a space or a number or another non-letter. Okay, so in this case we have here the backslash, the command. We can put optional parameter, our parameter, and then here it will be terminated because it should have a space or a number or a non-letter. But there are another commands that they consist just in a backslash and just one non-letter. For example, this is a command to write down in your PDF the symbol and here. If you use this without the backslash, it has another meaning that I'm gonna show you after. And then I have to say that LaTeX ignore white space after the commands. So to get a space after the commands, you need to write these brackets here after the commands, like in this example. So this command is writing LaTeX in this way, in here on top. So at the end, if you put the brackets, if you write the bracket, it will make a white space after. So special characters. All of these symbols here are special characters. For example, this one, it will create comments in your text document. So you can write wherever you want, and it will not be used as a text in your PDF. This one is used mainly in tables to separate columns and so on. You can find all of this after on internet, and we are going to explain it deeply in the hands-on part. So also you can define different group that you can set up, like I don't know, the bold, italic, or stuff like this. So you can select by groups, or you can also select by environment. That could be, for example, a figure, a table, or a list, or something like that. So floating bodies could be tables of figures, for example. And the main thing with these two is that they cannot be broken across pages. So LaTeX is going to try to find the better position or the position that you say in your document. For that, we use the placement specifier to give options to LaTeX to locate your image in your text. So For example, possible placement specifier are HTTP, that it means here where you write it, or top, bottom of the page, top of the page, or in a new page with only float on it. If you don't give this placement, it will be assumed that it's going to be top, bottom, or a new page with only floats. So if a float, I mean tables of figures, cannot be placed in the current page, this it will be deferred to a queue. So first in, first out. What I mean with this, if you write in your document a figure 1, if this one doesn't fit in the same page of where you write it, it's gonna be before the figure 2 after. And then we can use captions to add a caption of the floating body, for example, a table or a figure. I'm going to show you an example of both now. So how we create a table is using the tabular environment. So for example, here we create an environment here that is called tabular. Here we have another commands that it will create. It will define how many columns and the alignment of the columns. So for example, here we have 3 columns, and the first column has left alignment, the second column has center alignment, and the last column is going to be a right alignment. And here we put our data or our information. So we create first column is divided by this symbol, as I told you before. Then we put date and value, and here we have our 3 columns. And then to create a new row, we put these 2 backslash here, and we create a new row. And then we do the same thing, and we close the tabular environment. And we can put this tabular environment inside of the table environment to add a caption here. So this command, it will be look like this in our PDF or in our final document. So for example, for me, this is a bit annoying to do manually. So sometimes if you have a very big table, it could be annoying to put all of your data manually. So there are a lot of add-ons, for example, Calc to Latex that you can install on Excel or LibreOffice. Or you can use Xtable package in R to create these tables, and then you just copy and paste on your document, and that's all. For figures, you use the include graphic command. So in here, we create our environment figure. We said center the figure, and then include a graphic command where we give some optional parameter here. And then we say where are our figure in our computer. And it will be, the figure will be loaded like this, with also the caption that we are putting in here. So as you can see, this is very easy, and then the alignment is going to work, and LaTeX is going to try to find out the best location for your figure. One of the good features of LaTeX is writing equations, and very beautiful and nice equations. So you can use, for example, 2 different environments here. So you can use equation environment or align. Here I'm going to show you an example of align environment. So in here we use to align all the equations to the equal symbol. So you can see that all of them are aligned. Here you can see many different commands to write the different part of the equations. And LaTeX by itself, it's going to create also the numbering here that we don't have to worry about. This, I think, also you can more or less is the same structure than Word, I think, or similar, but I feel like it works better in LaTeX. So for referencing, this is another really nice feature, I think, in LaTeX that they always work. You don't have a problem with this, never. So to do cross-reference, you first need to label what you want to reference. For example, equations, figures, tables, sections of your document. So you label them, and then you could use these three commands. So it could be the ref command that it will refer to the number of the label, or a page ref that is refers to the page number of the labeled item, or cref that is gonna refer to the type of the item, if you know if it's known the type of the item. So this, it will look like this. So this is an example. So here, in here we have our environment, our equation, for example, and we put a label here, label equation. And this is a typical setup for the labels that I will recommend to use the type of your label. So in this case, equation, and then some letters or words that for you will be easier to find. And then here we can now refer to this equation like using the commands ref or the page ref. And you can see here that now we can refer to the equation 4 and on page 35, for example, in this case. So this is how it will look in your PDF. Citations also is very simple, I think, in LaTeX. You will need to create a separate, a new bibliography file type that is plain text ending in .bib that I'm going to show you after how it looks. But then in this text, you will have some labels, as I showed you before, and you will use some commands like citetap here for one style of citation, and then you put the label. Or you can use citet to cite another study, and in another formatting, this is another label. And then you can add the bibliography just using this command here. So this, it will look like this in your document, in your final document. Here is the first citation, and this is the second one. You can see that they are different style. And then the bibliography, it will be loaded and write it in this way here. The style of the bibliography, you can also change it, and it's very easy to do it in the preamble. So the bib file, it can be done manually, or you can do it using different software like Zotero or OneNote or Mendeley, that many of you, I guess, use it for managing your papers. So if you use those programs, you just can export, just select your papers. You can export as a bib file, and it will create this file here. So as you can see, here we define our label of the type of file that is an article, and then you can write the title, volumes, number, journal, author, years, page, DOI, as many as information you want. And this is this other article, and this is the other label. So LaTeX it will read this file, and you will be able to use it in your document to cite this information here. So The other thing that many people struggle when try to test LaTeX is the white space characters, that they are totally different than, for example, in Word. So, for example, the white space characters such as the space or the tabular, they are treated uniformly as a space. So several white space characters are treated like just one white space. The white space at the start of the line are generally ignored. Also, a single line break is treated as a white space. An empty line between two lines of text define the end of a paragraph, and several empty lines are treated as the same as one empty line. So this is basically, don't try to edit or try to find a formatting or your text. LaTeX is gonna do it for you, so you don't have to do many spaces for in your text document, because LaTeX is gonna try to find a better way to show you your document. So here there are some examples. So here, for example, we have 4 white space, and then between test, test, and test, we have 1 white space. And you can see here that all these 4 white space are ignored. And then we have one line between one white line between 2 text line. So we said, okay, this was the end of the paragraph. So it jumped down here. And again, these 4 white space here are ignored in here. So in the same way here, we have the 4 white space that are ignored here. And then we have just one break line here that is treated as a white space. And then this tabular thing that is basically ignored. So we have just one white space. And then here we have 4 white space that are treated like one, as I said. So here, and then we have 2 lines between text file here. So we have one line here and another here, and it's treated like one. So it's the end of the paragraph here. So we jump down here. And again, all of these tabulars and white spaces are ignored at the beginning. So this is maybe for most of you kind of complicated, can be complicated when you write, when you try to learn LaTeX from Word or any other text editor. But the idea is that you focus on writing and don't bother of the formatting. So here there are very good materials. So what I usually do is, just when I have a question, if I don't know how to do some stuff on LaTeX, I just Google it. And basically most of the answer I found is in Static Change website or Overleaf. I recommend to use both, but usually you just Google it and you will find it. So thank you very much for your attention. I hope that you learned something new and it's more clear for you how LaTeX work, and we can, if there are no questions, we can just go for the hands-on. But first, we would like to do some pictures. So also we can kind of mix questions, or maybe we can do question first and then pictures, and then we go for the hands-on part of the workshop. So thank you very much for everyone for listening.
Thank you. That was great. And very interesting, even though scary, at least for people who never touch it, I guess.
We will try to make it less scary in the hands-on part. I mean, you will see that it looks like difficult at the beginning, but it's not as difficult as it looks, I think. I know that this command thing when you write could be a bit scary, but you will see that the main thing I think in LaTeX is you just need to focus on writing. So you don't have to bother of formatting your text or putting some figures here down, here up, or the references doesn't work well, or the cross-reference doesn't work. I feel like you just need to focus on writing. That's the main point. And at the beginning, the learn curve maybe is difficult at the beginning, but then it will be much easier to write for you. That's why we think that LaTeX is a very good tool to use for writing.
Yeah, I would totally agree with that. So both César and me, we are both far from being like really professional LaTeX users. We're just using it for all of our writing, which we do. And I also have to Google a lot of stuff, but that's no problem because it's really a text command-based software where you can just Google your problem. If you find a solution, you copy and paste it, maybe change variable, and then it works. And it's not like click here, click there, do this. And all of the things that look scary in the beginning, for example, like the tables, if you have never seen this, I guess this is quite scary, but you don't really need to care about this because there are these nice software packages where you can just create your table directly from your data. And I think this has really big advantages. For example, if you have like a working routine where you have an R script or for an Excel table, and you do your calculations, and then you generate your output and put it in your document. And then when you see, okay, you redo your calculations because you get new data or you did an error or whatever, you can just redo it and then recompile your document, and you have already the new table in there. And you don't need to bother if you did it like the copying right or something like this. Yeah.
I guess I have a question, like I guess the big thing is in terms of collaboration, you know, sharing your document. So do you guys generally share, if you're working with someone, do you share the LaTeX code, or would you share like your PDF that you generate at the end? And like, or is there like a better, like what has been your experience in terms of collaboration wise?
You want to go, César, or should I start?
Okay, I can go. Well, depends. If my collaborator knows LaTeX, I give just the LaTeX document. Otherwise, I just have to give my PDF. And also you can comment and do some collaboration. But yeah, but also you can use, for example, I think Overleaf for collaboration is a very nice website that you can share your document, and well, you have to pay. It's not for a student, it's a bit, I don't know, maybe it's cheap or expensive, depend, but it's $80 per year, and you can share your document with six collaborators, and they can add comments or edit it and do the backtracking of your document as the same way is done in Word. So I think that's a very nice tool to collaborate because, for example, if we add the complexity of Git, for some people maybe to add a new level of complexity for collaborate is not the best, I think. But if everybody knows everything, yeah, I will say I will share my documents and follow my changes with Git, and that's all.
Yeah, because I guess one of the features that, I mean, when you use Word and things like that is like using like tracked changes, you know, and that's kind of, can that be done in LaTeX? In Overleaf, you can do the same principle.
Yeah, you can do exactly the same. Actually, I check it because I having this problem now. So I checked the other day, and you can do exactly the same. And even you can go back in your file completely, like other version of your file, even not only just the change of if somebody deletes some word, in your text file, you can accept or reject the change. Also, you can go back in time on your entire text.
I will try to show you this feature in Overleaf later in the hands-on part. If I forget, please remind me. Yeah. And then I totally agree with César. I guess if you just use basic LaTeX without any additional software or stuff, then the only way to do this would be to use Git or similar software, which of course is making it difficult or adding this extra layer of complexity. But with such softwares as Overleaf or services available, this is possible. Okay, if there are no more additional questions, should we do a picture, or did you already do a picture, Tyke?
No,
Would you like to say something?
Yeah, if people could maybe switch on their cameras just for a quick second, just for.
You can also cut it out, right, of the video.
Yeah, that's true.
If people don't want to end up on YouTube.
Okay, thanks. Yep, there we go. All good. Back over to you guys.
Okay, perfect. Yeah, thank you all for attending. I will continue with the next part, which is a little bit more hands-on. I hope you all got the email and already downloaded the stuff, but I will show it to you quickly anyways. So let me share my screen. So you can see now here the GitHub page of this workshop, where there is here a short text on installation of the LaTeX software and a recommendation for an editor to use. And then here you have 2 folders with the materials, so the presentation, which César just showed, and then here the examples and tasks we're going to work on today. And you can either clone the Git repository if you use Git, or you can press here on code, and then there's download zip, and you can download the files, or hopefully you already have done so. And I will go with you through this main text, which is a small default text, which you also then can use later on for your own text. So this is also how I usually work. I don't start from zero always at the beginning. I use an old LaTeX file, remove the content, and then just start from there. I will go through all of this in Overleaf, but just to be complete, I will also quickly show you Text Studio, so the IDE we recommended, or so the editor. So if people are using this, that they know how it looks like. So, oops. Okay, so here you can see now how it looks with me. So I have I'm using a dark theme. It might be look a little bit different for you. What you can see here is, of course, you can open a file. I already have it open. So I have this file open here. This is the source file for the presentation, which César just showed you. And here is just the regular text editor where you have the text. Then you have here these 2 green arrows, or you can press F5 button, which will compile this text to the PDF document, which you can see here now. And down here you have a small terminal where you can see here now some messages. So process exited normally. If you have an error in there, it will give you an error message. And then here on the side, you have the side panel where you have different things. So for example, here you can see the 2 text files, which I have open here. And then if you have structure in this, then you can already see the sections, the difference here, and jump through it. And then there's some help here for mathematical symbols and equations. But as I said, I will be using Overleaf for now because from last with this workshop, most people were using Overleaf because it's simply easier. Installation of LaTeX can also sometimes be a little bit dreadful, I would say. I hope everyone downloaded the files and either has a LaTeX distribution running on her or his computer or has an Overleaf open. I will share now my screen for the Overleaf. So I am using Overleaf here. Oh wait, let's just go back to the start page. So this is how the start page looks like with me. I'm not using the official Overleaf. My university is providing an own Overleaf instance, but it should look the same, besides that maybe you don't have like the TU Dresden logo up here. And you can create a new project. I already did this here. Say blank project, then give it a name. I will just say first document. And then it will open an empty document here, which is not even completely empty. So you already have the document class, which César explained in the beginning in here. You already have one additional package loaded. You have the commands for title, author, and date in here. And you have the document environment, which is everything, as I said, between begin document and end document, where the actual content of your document is put in. So if you have this, you can upload the files which you loaded from GitHub. So I can choose from my computer the files, and I will just use all of the files, select all of the files from the examples and tasks folder. It will upload them, and it will say here, oh, okay, sorry, that was a little bit quick. So there was one warning that main.tex is already in this project and that it will be overwritten, because this is often the title of your source file, or by default, at least, it's the title of your main source file. It's called main. And now we can see here, I have all this ready-made document which we prepared. On the right-hand side, we can already see the document. This is wrong. This is still the document from this newly created. And then up on the top here, we have this green button where it says recompile. And if we press this, it will generate the PDF from the source file. Then we have here again this side panel, where you can see the other files which I uploaded, which were in this folder. So those are, for example, the figures which we want to include in this document. This is this .bib file, which contains our citations. And then there's another .bib file for the solutions. There's also another .tex file, which contains the solutions. So we won't look at those two today. So in this document at the end, there are some tasks for you. And if you want to get the solutions for these tasks, you can have a look at this file if we don't go through all of them together today. Okay. And then here in the left top corner, there's this menu button. If you click this, you can then again download these files here. So you can download either all of the files as a zip file, or you can just download the PDF file. And then there are some settings here. I just increased the font size a little bit. I hope you can see well. If you have any problems seeing stuff from the screen I share, just yeah, let me know, or say something, write a chat message. Okay, so let's have a look at this document. César explained this already, all of the text files, the first valid comment always has to define the document class. So in this case, we're just using article, which is the basic document class for a short article. And if you later, for example, are going to use LaTeX to write a paper, lots of journals have their own document class where you then have to change the name here. And sometimes they have a so-called class file, which is a text file, which is ending in .cls. And then you just have to include this file also in the same folder. And then usually it works. Then we have the preamble here. I will just insert one white space so it's a little bit clearer here. So this is the preamble. We have lots of packages here that we think are quite useful. And we probably won't need all of them, but yeah. So for example, here we have again this hyperref, which César also mentioned. We have here the Babel package, which is for the English language, so that, for example, words are split at the right point if a word is going to be split over one line, that the hyphen are going to be put at the right point. And then there's a package here which we can use. This is also one of the tasks to add line numbers, for example. Then we have here some other commands which are giving some meta information about our document. So first the title, which is here example LaTeX document, which you already can see here in the compiled document. Then we have the author name, which is a author. And then we have the date, which is set to a command, which is \today, which is always giving the date of the day you compiled it. So you can see here, February 23rd, 2021. Also, if you change the language here in this bubble, it will also change the name of the month that is automatically generated here, for example. And then we have begin document. So everything that is between begin document and end document is the actual content of our document. We can click here on the small arrow and it will just close all of the lines, and we can see there's nothing coming after end document because then it's over. And then we can see here, this is all of the content we already put in there for you to have a few examples and something to play around with later on. And then we have the first command here, which is make title, which is generating the title. So most of these commands are pretty self-explanatory, and I will just go through them now, and then we will go to the tasks. And if you have questions, as I said, just go ahead and ask. Then we have here a command which is called new page, which is also doing exactly what the name suggests. It's creating a new page. If we wouldn't have this command here, we would have the title, and then the text would begin after some space that is predefined. Then we have these three commands, which César also mentioned: table of contents, list of figures, and list of tables, which are automatically generating here these nice tables, as the name suggests. So we have this table of content, and as we loaded the hyperref package, we can also click on one of these, and the PDF will automatically jump to the corresponding page. And then list of figures, list of tables. Then again, a new page to clear it, and now here the main content is starting. And then we have here one command which we did not mention in the introduction talk, but which is quite important. And this is \section, and this is telling LaTeX the structure of your document. So this is, of course, here now a new section with the name introduction, which you can see here. And then here we have the next section, bullet points and numbering, and you can see here, next section, bullet points and numbering. Note also the numbers are done automatically. And if you want to have another style of numbering or something, you have to give a command in the preamble. So we have the first section, which is introduction, where we just have a little bit of text. You can also already see in the document here, there's a figure already. even though here there's no figure will be coming in a minute. So we have some text here, some special characters, and already a citation for a paper here, and we already have a label here, so we can refer to this section later on in the text. We will come to this. Then here we have this figure. As César explained, we have here the begin figure, end figure is a floating environment, and the floating environment is letting LaTeX decide where to put the figure in the document once it's compiled. And we have here this placement specifier T for top. So it tells LaTeX basically, okay, here I have my figure, put it wherever it suits you, but please put it on the top of the page. And you can see here, it's directly at the beginning on the top of the page. So here we have the name of the file, which has to be in the same folder. So you can see here, universe.jpg. One thing to note, you don't need to have the .jpg ending. LaTeX has an internal list of allowed file names for figures, and it should work just as fine without this. Let me check if I'm right. Yes, okay, so I click recompile, figure is still here. So you don't really need this, but I think sometimes it's good to be explicit about things. And then here we have the caption, and you can see here one thing. We have the command \caption, then we have the square brackets where we have just the universe, and then we have this curly brackets where we have the universe picture from NASA and the link to their homepage. And you can see here in the caption, it has automatically generated figure number 1. And then there's just the text from within the curly brackets. The text from the square brackets will just be used for the list of figures. So it's a so-called short caption and long caption. So if you have very long descriptions of your figures, you don't want to have them, you don't want to have them in your list of figures, you want to have something shorter, and you can supply this here in this first additional argument. So then our next section is about bullet points and numbering. It's quite easy to create such bullet point lists or numbered lists. We have an environment for that, like for almost everything. And for bullet point, it's called itemize. Here, begin itemize, end itemize. And then we have always \item for a new item, then whatever you want to put there. And then new line, again, \item, and so on. And you can nest these. So instead of an item, I can set a new itemize, or in this case, I use the enumerate environment, which is basically the same, but instead of here these points, you will have a numbered list. And you can do this a couple of times. Okay, next section is about equations. So here we have a very simple equation for a linear regression function. And then we have here this align equation, which also César showed in the presentation, where we use the and sign, you can see it here, in front of the equal to tell the environment where to align this equations. If you remember, the columns are also using, the tables are also using the and sign to separate the different columns. So you can think of this as just being a table with equation in it. And then in the first column, you have here y1, y2, y2, y3. And in the second, you have the rest of the equation. And thereby, they are aligned here. And if I want to use the and sign in the text, I hope you can see this as it's done here. I have to use this command with \ and the and symbol. If you don't do this, you will get an error. I can quickly show you. I remove it, press recompile. And now here, there's a red arrow, and here misplaced alignment tab character. And there's some more explanation. And the nice thing about overleaf is it really explains to you in detail. If you want to write an ampersand in text, you must write it as backslash. If you use a regular LaTeX, sometimes the error messages are not so nice and easy to understand. This is another advantage of overleaf, I would say. Okay, then our next section is about equations in text. So here we don't use section because it still belongs to the sections about equations. We use subsection, and this will create then here 3.2. You can go down to subsection, and then if you want to go lower, you have to use paragraph. But I don't think these details are too important right now. You might forget it, but that's no problem. You can just Google it and you will directly find the answer. So if you want to write equations in running text, you can use the $signs in running text and then write your equation. And then you can see here, we have here this equation within the running text. So next step, or next section is about tables. You can see here, it's again, the tables section is beginning here, but the actual table is here at the bottom of the page. And this is again because we use a floating environment. We have here this begin table, which is the floating environment, end table. So everything between begin table and end table, we tell LaTeX, please put it at a place where it is best suited. And we say with this placement specifier, please put it at the bottom of the page. And you can see here at the bottom of the page is our table. Then we have again here this command centering, which just means center the table in the middle of the page. If we remove it, then it will be on the right side here. Then we have again a caption here. Again, we have a short caption and a long caption, even if the long caption is not really longer in this case, but it could be way longer. We again have a label here. And here we also refer to this label. And here we use cref, which is automatically writing table 1. If we just would use ref instead of cref, we would just get this number 1, so the number of the table. So I remove the C and just use ref. Now we see here, there's just a 1. Can I zoom in here a little bit? Yeah. I guess this is better. So you can see here now, we can refer to 1, we can refer to ref, and if I use cref, it will automatically get the name. Now it says we can refer to table 1 because it also automatically writes here table 1 in front of the caption. Okay, and then here is an example for a table. As I said, they might look a little bit scary in the beginning, but basically we have, again, an environment, which is called tabular. Then we have this argument here where we have a number of letters. And for each letter which you put in here, you get 1 column. And then the letters themselves stand for the alignment. So L means left aligned, R means right aligned, and C means centered. And you can see here we have 3 columns, and all of them align on the left side. And then we have here the content of the table. We have here the header, name. Then we have this and symbol to tell, okay, next column, ID, next column, value, backslash means new line. And then we have this command here, hline, which means horizontal line. So you can see here above and below the header, we have a horizontal line drawn. And if you want to draw a vertical line, you can do this by adding a vertical line. I'm not really sure how this character is called. I'm sorry about this. So this big vertical line, which you use to express the absolute value in mathematics, or in terminal terms, it's the pipe operator. Can someone tell me what this character is called? If not, you can see it here. It's this big slash, and if I slash vertical line. And if I insert this here, you can see now here there's a vertical line along the whole column. Okay, so then we have more rows, and then at the end again a horizontal line. I removed this, but it's still in here because I have not pressed recompile. Once I press recompile, it will be gone. So this is also part of this not being what you see is what you get. So you have to change it here, and it looks different in the source code, and then you have to compile your document. So the next section is about figures. We already had one figure in the beginning. And then here we have an example where we have two figures next to each other. And therefore we use this subfloat function. I will not go too much into detail here because you can just look at this yourself. Okay, and then we come to the last point, which is tasks. And this is where now your work begins or your fun begins. So we have compiled a list of tasks for you. So, or actually we have compiled two lists of tasks. I will start going through the first 3 or 4 together with you, and then I will leave the field to you, and you can try to change things yourself and play around. And if you have any problems or questions, César and I will try to help them for you. Okay, first I will go through tasks, then I will ask if there are any questions, and then you can start working. So we have the basic tasks and we have advanced tasks. So this is a little bit how we personally thought they are to be arranged in terms of difficulty and also in terms of how important they are. So the first task would be to change the author name to your name. Then the second task would be to change the title of the document. So those two are probably quite easy. Then the next one would be to include some of your own text. And I would also advise you to play around a little bit with this white space thing, which we explained to you. And then there's something about making some of your own text bold and italics. So this is a little bit more tricky. I'm not really sure. Either you have to Google it, or we already have hidden the answer within this document. I can't remember, to be honest. And then here, change the font size of some of your text. So those are actually things which you usually would not want to do in LaTeX, because you want just to focus on the content and not on the formatting so much. But still, I think it's quite funny to play around a little bit, or interesting to learn also some of these concepts. And then you should include your own favorite equation. You should include your own figure. You have to play around with the placement specifier of one of the floats. Change the alignment of one of your figures from center to left-sided at your own table. So this is really the hard stuff starting. Refer to a subsection and the page it's on. Add your own reference and cite them. So this is something I forgot to show you. I will show you this before the references part, and then add some formatted source code. This is maybe for people who use a lot of programming also interesting. And then advanced tasks, I will not read them to you. So quickly before I'm done, I showed you right at the beginning of the document, we already have one citation here, which is here to a paper of Matt Hipsey, and then here to the Hitchhiker's Guide to the Galaxy. So we have this command, and here we have this label. And at the end of our document, we have these two commands. This one, the lower one, bibliography, César showed you in the presentation. This is giving the name of the text file where the information is stored. We call it here references. And you can see here, there's this file references.bib. Again, you don't need to have the ending here. And if we open this, we can see here different entries. This is the book, and this is the label which I use to refer to it, and this is the paper and the label which I refer to it. Again, this is a part of LaTeX where it looks kind of scary if you have these things, but it's super easy to get this, and I will show you this quickly. So you can, for example, go to Google Scholar. One O too much, and then you can put in here paper. Okay, I don't immediately find the Matipsy paper, but I will just take the first paper which comes up here. And you can see down here are these small quotation marks. And if you press this, you get here the citation to copy and paste to your text document. And down here, you have BibTeX. And if you press BibTeX, you get here this thing. You can just copy and paste it, include it into your text document. And then if you want to change the label, which you use to refer to it, you can change it here, and that's it. And all of the journals provide this text file. So you really don't need to do anything. It's really convenient. And then the second command, which we have here, is about the style. So how the references are then printed here. And this is also something which is really, really convenient. If you say, okay, you don't like this, you can. Now the thing is, I have to remember a valid name. I'm not really sure if I'm going to be able to do that. I think this should work. Let's see. Probably I will get an error. No, I will not get an error. And now the style of the citation here has changed. And you can do this even if you have hundreds of different citations. No need to do anything, just change the name here. And again, if you try to prepare a manuscript that you want to submit to a journal, the journals have these style files ready. You just need to download them. You can put them in the same folder, type in the name, and it will be in the style the journal requires, and it's done. Okay, now I'm finally done with my monologue. I will quickly stop sharing my screen and give you first room for questions, and then you can start playing around, and probably you will have lots of more questions.
Thanks, Johannes. That was really interesting. How long do these take to compile? Like, if you want to quickly check that you've not ruined your whole document, is it going to take you like 10-15 minutes for it to recompile each time? If you have like a really long thing?
No, it's really fast. So it's kind of depending, of course, on your computer and document, but it's you can see. I just press it here, and then it takes maybe 10 seconds. And this is like on the web. If I do it on my computer, it's, I don't know, less than a second. I don't know.
Okay, so it's quicker if you're doing it locally. Yeah. Thanks.
But just on that, I guess, if you say, for example, you embedded some like R script to generate a figure, or you wouldn't do that. That would be outside of your workflow. Would like that potentially, if you have it like building everything from scratch?
I mean, there are different ways to do that. The fancy way probably is that you can even use make files. I just learned that currently, and it's quite amazing if you want to learn something else. So, and you can have your whole building routine, which will check if your R script has been changed. And if your R script has been changed, it will run your R script, create the figure, and then embed the figure, and then recompile your text document. There's a thing called TIX, which is a package which can be used to draw figures within LaTeX. And you can also create such figures from R. I think there are packages, but the way I usually work is I create vector-based graphics in my R script, mostly PDF, and then I just include the PDF files in my LaTeX file.
Okay, just wanted to add a bit on that. I mean, with LaTeX, you can also read some data and with text create your figure, but then it will take more to compile your document. So maybe it's kind of better to do it the way that Johannes said. But yeah, I mean, but then you don't have to worry to write with the same font in your figures than in your text. So if you create it inside of LaTeX, all of the things are gonna be in the same way. So then maybe it looks a bit nicer when you do that, or you have to be worried about to write in the same font in LaTeX in your figures and everything.
Yeah, thank you guys. Now, yeah, let's see how it works when we play around. But I was wondering, because to me it feels maybe the way you explain it, or it feels that you really know it's useful when you really know the structure, or maybe it's because so maybe I was thinking it's something that you do maybe to first write in Word or like have something around, and when you have all the figures, all the subsections, then you create this, or it's really useful to manipulate so I don't know, I have the feeling that if I had to start to create one, I would like to know exactly the structure of my article, or to start from zero, I would be like, okay, how should I start, you know? But maybe once you get advanced, it's efficient in this way.
So I can only answer for myself. César will probably say something after me. I never learned to probably use Word, to be honest. And I always have been using LaTeX since I started my bachelor. So I would not do that.
Okay,
and
yeah.
I think once you get to know it a little bit, it's not that scary anymore. And the way I usually start, if I start a new document, I start by just including the sections with an idea of how I want to structure my document, also from the content, and then just some bullet points. And then I just jump around wherever I work and insert sections and play around and refine it step by step. So I really start with this skeleton of just this empty document. As I said, I always just take my last document of the similar type, remove all of the content, and then start by adding sections. I mean, for scientific writing, you usually have the same structure anyway, something like introduction, methods, results, discussion. So you just remove the content, but if you want to write something else, maybe with a little bit different structure, start with the sections and then some bullet points, what should go in there. Or maybe you already have some preliminary results in terms of figures or tables, which you can add. Yeah, this is the way I work.
And then I had another question. Sorry. Yes.
Just I want to show you something about your first question, just quickly, because I think it's important in sense of if you are writing just your draft or you don't have any idea of your structure, I think it's even easier in LaTeX to change all of your work. For example, here I'm gonna share a bit. Again, the same document that Johannes was showing. So here you have, I don't know, introduction, bullet points, and equation. So now we say, okay, we want to have the bullet points as our first section. I mean, I don't know the structure. I at the beginning, I say, okay, this is my structure, but no, I don't like the introduction to be the first. I would like to have the bullet points and numbering at the first. So here, for example, I'm just gonna select, and I have it in Vim, sorry. I think here, if I select here, can I just, yeah. So I cut it and I put it just at the beginning, and then I recompile. And now my bullet points, it's my first So all of the numbering, for example, are going to be okay. So you don't have to worry about that. So if you don't know your structure, doesn't matter. I mean, you just write and then you can edit it, and then LaTeX is going to find a way to make your document as it should be. For example, with the numbering stuff.
Yes, yeah, I guess. Yeah, just because this workshop went perfect, because I am starting to write my thesis. So then now I'm just thinking, should I start to learn LaTeX? You know, in terms of a structure, it looks really great. Like you don't have to worry about if figure 1, figure 2 has been in different orders or all these things. But because it's a new thing, I always think I will waste too much time learning it. But you sell it really nice. So let's see how it works now. But my last question was about, maybe you said it already, but for the references, this like this file that you have besides with your citations, like you have to build it like based on the references that you want to include, or you can extract it, for example, from Zotero, or I just missed the link. So I understand how you add a reference in your text, but how do you create this reference storage?
Yes, you can directly create it from Zotero. You can, if you use Zotero. So I'm using Zotero. I can select all of the papers. So I usually add tags to the papers which I want to include in a certain work. And then I can just click the tag. I have all of the papers. You can select all of the papers and then right click and say export, and that will just generate such a file. The only thing which you need to take care of is the name of the labels. So Zotero will automatically generate these labels, which you then use to refer in your text. But the nice thing, I'm not sure if this is also working in Overleaf. I can check it out, but I'm using mostly Text Studio, and there, if you have, if you start the command, so this is, I can show you this. This is also in Overleaf the case. It will autocomplete your commands. So for example, if I say cite, you can already see here it's showing me all of the possible commands. And then if I use the cite et, then it also, yeah, this is what I wanted to know. It's also already suggesting all of the possible names which are giving. Then you just have to take care that your label which you select has some meaning, so you can understand what it means. And this is why the way it's done by Zotero usually is something like name of the author, year, and maybe name of the paper or whatever. And then I can just select it here. I can recompile. So this takes a little bit longer if you add a new citation for recompilation, because it has to be done twice. But you can see for once, it automatically added the citation here to the references. I will zoom in a little bit. So here now this A. Montari paper is included here, and at the point in the text where I edited here is now, so I used cite et, which means cite text, so it's without brackets around it. And if I use the cite p command, just after it, it will cite it in brackets. So you can see here now it's in brackets. And also, if you at a later point you decide, oh, I don't like the way the citations are done, I don't like what the journal I'm going to submit, they don't want round brackets, or for my dissertation, I don't want round brackets, I want numbers or whatever, then you can add here the options for the snapbit package. You can say, for example, numbered, I think. Again, not 100% sure. In the worst case, you have to Google it and then copy and paste it. But okay, now at least I have sharp brackets here, and I think the reason why I don't have numbers is because of the bibliography style, which I choose down here. I also got an error message here, and yeah. So the option numbered was not declared in the packet net bitch, maybe netbib, maybe you misspelled it. Okay, so I spelled it wrong, but at least you saw that now the brackets are not round anymore. They are square brackets, and if you know the right command, you can easily change the style of just numbered or whatever you like. Okay, I don't see any more questions at the moment. Are you already playing around a little bit in the document? Okay, perfect. Just try to go through the tasks. As I said, we have the solutions online as well, or almost all of the solutions. And if you have any trouble or questions during working now, just say something and we will try to figure it out together.
Yeah, so I guess I'll stop the recording now, and then